of things quickly that come up all over the place, and they're an overlap with the external evaluate reports. Limitations and assumptions. When we do use probability, we're usually assuming things. A limitation is a problem in the background with what we're assuming. And so there's an NZQA example, and you've got access to all of them. Information based on year 13 students being applied to year 11 students. Now we know from evaluating reports that that is extending of results. And so that sort of thing we keep an eye out for in the probability situations. Are the numbers we've been using or the numbers we're going to use, are they based on something solid, or are they based on something that looks similar but that's not quite right? Examples of this will come up just as you're working for exams. We'll just look at another type of thing. So when you'll often be asked in a question, what assumptions are you making? This is taken from an old exam question. And they say on a January day, the probability of a flight being delayed in Wellington is about 37%. So if we're going to use that 37%, there's a number of flights coming in and we're working out the probability one or two or more of them are delayed. What are we assuming? To use that, we're assuming that the conditions that lead to that 37 are still in place. Delays in airports are usually dependent on weather. It's the main thing. I suppose breakdowns is the other. So we're assuming the weather is the same, and the weather isn't the same day on day. So if it's a different day, the probability of being delayed due to the weather might be different. That we're assuming that delays would be the same throughout the year. If it happened to be 37% of flights in January, that might not be the case. If we're in June when we get out of the school holidays, things might be different. Numbers of flights change as the years go on and the weather changes, so that sort of thing. So where assumptions are background ideas behind the values that we use. That's one type of an assumption. A second one, and this one comes up all over the place, is the idea of independence. And we've used this in probability up to now and just not called it something. When we say and we multiply two probabilities together, we're assuming a thing called independence. And that means that what happened in the first event and the second event that we're multiplying the probabilities for don't impact on each other. Rolling a dice is a good example. If I roll a 2 on the dice, what is the probability of getting... If I roll 2 dice, what is the probability of getting an even on the first and then a 5 on the second? Now, when the dice roll, what happens on one dice is completely independent of the other. So the probability of getting an even on the first is 3 out of 6. The probability of getting a 5 on the second is 1 out of 6. Those two events are independent. What happens here doesn't affect the likelihood of the 5 turning up on the other dice. So the probability of getting an even and then a 5, we take the probability for one event, times it by the probability of the other. Anytime we use that times, we're assuming that the two probabilities we're multiplying together are independent of each other. And that's quite an important thing that comes up as time goes on. You'll see more of it.